North Africa, November 1942. The scorching sun beat down on a makeshift testing ground 30 kilometers west of Alexandria, Egypt, where a small crowd of Allied engineers and military observers gathered around what appeared to be the most unconventional piece of ordnance they had ever witnessed. The device looked like someone had welded a massive soda bottle to a standard artillery shell, its ungainly silhouette drawing barely concealed smirks from the assembled crowd. At the center of this skeptical audience stood Lieutenant Marcus Webb, a 28-year-old mechanical engineer from Detroit whose dark skin made him one of only a handful of black officers in the entire North African theater. He adjusted his wire-rimmed glasses and pretended not to notice the whispered jokes rippling through the crowd. What none of these doubters could possibly imagine was that within 72 hours, this ridiculous-looking contraption would revolutionize urban warfare and save hundreds of Allied lives in one of the most brutal confrontations of the Mediterranean campaign. Before we dive into this story, make sure to subscribe to the channel and tell me in the comments where you're watching from. It really helps support the channel. This is the account of how wartime desperation, individual brilliance and institutional prejudice collided in the desert, producing a weapon that military historians would later recognize as a crucial stepping stone toward modern bunker-busting technology, and how one man's refusal to accept dismissal would transform the trajectory of urban combat operations. Marcus Webb had arrived in North Africa 6 months earlier, assigned to the 51st Ordnance Battalion as part of a segregated engineering unit responsible for ammunition handling and basic maintenance. The army had taught him to repair existing weapons, not to design new ones. His degree in mechanical engineering from Tuskegee Institute carried little weight in a military establishment that routinely assigned black officers to service roles regardless of their qualifications. But Webb possessed something that transcended formal authority: an obsessive curiosity about how things worked and an inability to accept that any problem was truly unsolvable. The challenge that would consume his every waking moment had emerged during the Allied advance through Libya. German forces, retreating toward Tunisia, had transformed dozens of small coastal towns into fortified strongpoints. The defenders used reinforced concrete bunkers, many of them pre-existing Italian colonial structures, now enhanced with additional fortification. These positions were proving nearly impervious to standard Allied artillery. A typical bunker featured walls 1.5 meters thick, constructed from concrete, reinforced with steel rebars and filled with crushed stone. Inside these fortifications, machine gun crews could operate with near impunity, cutting down advancing infantry while remaining safe from everything except a direct hit from the heaviest caliber guns. The problem was one of simple physics, compounded by tactical reality. Standard high-explosive shells, even from 155mm howitzers, were designed to burst on impact, creating fragmentation and blast effects. Against open targets or light fortifications, they were devastatingly effective. But when they struck thick concrete, most of their energy dissipated outward and upward. The shells would crater the surface, sometimes creating impressive-looking damage, but rarely achieved the deep penetration needed to compromise structural integrity or harm defenders inside. Captain James Rutherford, the senior ordnance officer for the sector, had watched 3 separate assaults fail against a particularly stubborn bunker complex near the town of Burat. The Allied casualties had been severe. 63 men from the Highland Light Infantry had become casualties attempting to cross 200 meters of open ground, while the German defenders remained safely entrenched. The after-action report sat on his desk, its conclusions frustratingly simple. Without specialized bunker-busting munitions or significantly heavier artillery, reducing these positions would require either prohibitive casualties or time-consuming siege tactics that the overall campaign schedule could not accommodate. Webb had read that report. He had also read everything else he could find about the bunker problem, including technical assessments from British engineers and captured German documentation about defensive construction techniques. More importantly, he had examined the few bunkers that had been successfully reduced, studying the damage patterns and trying to understand what had actually worked. The breakthrough had come not from military literature, but from his memory of industrial drilling operations he had witnessed at an automotive factory in Detroit. He remembered watching pneumatic hammers punch through reinforced concrete using focused, concentrated force rather than dispersed energy. The principle seemed applicable. What if you could make an artillery shell that did not explode on impact, but instead drove deep into the target before detonating? The concept was not entirely new. Armor-piercing shells used delayed fuses to penetrate tank armor before exploding inside. But those were designed for relatively thin steel plate, not meter-thick concrete. The forces involved were completely different. Webb's innovation was recognizing that the solution lay not in strengthening the shell casing, which would make it too heavy and slow, but in adding an external structure that could absorb and redirect the initial impact forces. His design centered around what he called a penetration collar, essentially a steel cylinder that fitted around the nose of a standard 105mm artillery shell. The cylinder was filled with a carefully calculated mixture of sand, lead shot, and a small amount of quick-setting concrete. When the shell struck a hard target, this collar would compress and deform, absorbing much of the initial shock, while the mass of the filling drove the shell deeper into the target. The deformation was key. As the collar crushed, it created a momentary cushion that prevented the shell from shattering or detonating prematurely. The shell's existing delayed fuse would then trigger the explosion once the projectile had penetrated as deeply as physics allowed. The prototype looked absurd. The collar gave the shell a bulbous, bottle-like appearance that violated every aesthetic principle of military engineering. It was ungainly, asymmetric, and appeared far too fragile to survive being fired from a gun. When Webb presented the concept to Captain Rutherford, the response had been polite but dismissive. Rutherford leaned back in his chair, studying the sketches. "Lieutenant Webb, I appreciate your initiative, but artillery design is an extraordinarily complex field. The specialists at Aberdeen Proving Ground spend years developing new munitions. I'm not sure a field modification is the answer here." The unspoken subtext was clear enough. Webb recognized the tone, the same careful courtesy that had accompanied every limitation placed on his career, every assumption about what roles were appropriate for someone who looked like him. He kept his voice level and professional. "Sir, I understand the concern, but we have the materials here, and I can fabricate a test unit in 48 hours. If it fails, we have lost nothing but some scrap metal and a single practice shell." Rutherford considered this. The campaign was stalled, casualties were mounting, and if this unconventional shell actually worked, even marginally, it might save lives. "Very well, Lieutenant. You have your 48 hours, but this stays unofficial. If it works, we will discuss proper channels. If it fails, this conversation never happened, understood?" Webb understood perfectly. Success would have many fathers, failure would be his alone. He worked through the night in a corner of the ordnance depot, assisted by 2 enlisted men from his unit, Corporal James Washington, a welder from Pittsburgh, and Private First Class Robert Chen, a machinist whose family had been interned in California, but who had somehow convinced the Army to let him serve. Together, they fabricated the collar from materials scrounged from a damaged truck chassis and a partially destroyed Italian warehouse. The technical challenges were immense. The collar had to be strong enough to survive the acceleration of being fired, but designed to crush in a precise sequence upon impact. Too strong, and it would not deform properly. Too weak, and it would disintegrate in the gun barrel or shatter uselessly against the target. Webb calculated the optimal mixture for the filling through a combination of engineering principles and intuition, testing small samples by dropping weights on them and measuring the deformation patterns. Washington proved invaluable for the welding work, creating joints that were simultaneously strong and designed to fail at specific stress points. Chen machined the internal components with a precision that seemed almost impossible given the crude equipment available in the field workshop. When Webb explained the physics behind each element, both men asked questions that sharpened the design. Chen suggested adding spiral grooves to help stabilize the shell's flight. Washington proposed reinforcing the rear of the collar to prevent it from shifting backward during firing. 72 hours after beginning, 24 hours past Rutherford's deadline, they had completed not 1, but 3 prototype shells. Each weighed approximately 18 kilograms, significantly heavier than a standard 105mm round. The additional weight would reduce range, but for bunker targets, engagements typically occurred at relatively close distances where this would not matter. The testing ground west of Alexandria was chosen because it was remote enough to avoid attention, but close enough to transport the heavy shells and a borrowed 105mm howitzer. Rutherford had approved the test with obvious reluctance, and word had spread through the engineering community. Nearly 30 officers and enlisted men gathered to watch, their expectations clearly low. Colonel Arthur Pemberton, the British liaison officer for ordnance development, examined the shells with barely concealed amusement. "I say, Webb, this looks like something from a Jules Verne novel. Are you quite certain this will not simply explode in the barrel?" Webb had run the calculations a dozen times. The structural integrity should hold. Should. "The design accounts for the firing stresses, sir. The collar will compress slightly during acceleration, but should remain intact until impact." "Should," Pemberton repeated, his tone making clear what he thought of should. "Well, let us see what happens. We have constructed a rather substantial target for you." The target was impressive. A concrete block 3 meters square and 2 meters thick, reinforced with steel rebars in a pattern matching German bunker construction. It had been positioned 400 meters from the firing position. For comparison, a standard high-explosive shell had already been fired at it, leaving a crater approximately 30 centimeters deep on the surface, but causing no significant structural damage. Webb personally supervised loading the first prototype. The howitzer crew, all British artillery veterans, handled the unusual shell with obvious skepticism. The gunner, Sergeant Thomas Brooks, shook his head as he adjusted the elevation. "No disrespect intended, sir, but I have been firing these guns for 6 years. That thing is not going to fly straight. The aerodynamics are all wrong." It was a legitimate concern. The collar disrupted the shell's normal streamlined shape. Webb had tried to account for this in the design, but there was no way to be certain without actual testing. "Let's find out, Sergeant. Range 400 meters, direct fire." Brooks made his adjustments and stepped back. "Gun ready, sir." Webb took a breath. Months of work, his reputation, possibly his career, all concentrated in this moment. "Fire!" The howitzer roared. The recoil was normal, no indication of structural failure in the barrel. Webb's eyes tracked the shell's flight. It seemed stable. The trajectory perhaps slightly different from standard, but not wildly erratic. 2 seconds of flight time stretched into eternity. The impact was unlike anything the observers expected. Instead of the sharp crack of a typical high-explosive detonation, there was a deeper, more resonant boom. A massive plume of concrete dust erupted from the target. When it cleared, even the skeptics fell silent. The shell had penetrated completely through the front face of the concrete block and detonated deep inside the structure. The rear wall had blown outward, leaving a hole nearly 2 meters in diameter. Massive cracks radiated from the impact point. The target had not just been damaged, it had been structurally compromised in a way that would render any real bunker uninhabitable. Pemberton approached the target, studying the damage pattern with a professional's eye. He turned back to Webb, his expression transformed. "Good Lord! How deep did it penetrate before detonation?" Webb was still processing what he had witnessed. The concept had worked, but the reality exceeded his calculations. Based on the fuse delay, approximately 1.2 to 1.5 meters, sir. The collar absorbed the initial impact exactly as designed. The British colonel walked around the shattered concrete, running his hands over the fractured edges. "This is remarkable. Absolutely remarkable. Captain Rutherford, I need to make some communications immediately. This needs to reach Theatre Command today." Rutherford, to his credit, nodded without hesitation. "Lieutenant Webb, prepare a full technical report. I want specifications, manufacturing requirements, everything, and we are going to need more prototypes, as many as you can produce." The second and third test shells performed similarly, confirming the design's reliability. By evening, Webb found himself in a tent with more senior officers than he had ever encountered simultaneously, explaining the penetration collar concept to men who hours earlier would not have given him a second glance. Major General Robert Harrison, Deputy Commander for Allied Logistics in the region, listened to Webb's presentation with intense focus. "How quickly can we manufacture these in quantity, Lieutenant?" Webb had anticipated the question. "Sir, with proper facilities and materials, a trained crew could produce approximately 8 to 12 shells per day. The collar fabrication is the bottleneck. We need sheet steel, welding equipment, and the correct mixture for the filling. The shells themselves are standard 105mm rounds with modified fuses." Harrison turned to his logistics officer. "What do we have available?" "We can divert materials from the depot at Tobruk, sir. There is also a Royal Engineer Workshop battalion that could be assigned to production. If we prioritize this, we could potentially produce 100 rounds within 2 weeks. 2 weeks. Webb's mind raced through the implications. The campaign was approaching a critical phase. Within 2 weeks, Allied forces would be assaulting major defensive positions around Tunisia. If his shells could reduce bunkers effectively, the casualty projections would change dramatically. Harrison made his decision. "Make it happen. Lieutenant Webb, you will oversee production personally. I am detaching you from your current unit and assigning you directly to my staff. You will work with the Royal Engineers to establish manufacturing procedures and quality control. I want every shell tested before deployment." It was the opportunity of a lifetime and a crushing responsibility. Webb thought of the men who would be attacking those bunkers, whose lives might depend on whether his design worked consistently under combat conditions. "Understood, sir. I will not fail you." The next 13 days were a blur of activity. Webb worked with teams of British and American engineers, translating his prototype into production specifications. Each collar required precise measurements and specific welding patterns. The filling mixture had to be exact. Too much sand and the collar would be too rigid. Too much lead shot and it would be too heavy. He developed testing procedures that could verify each shell's integrity without requiring actual firing. Private Chen proved invaluable, creating jigs and templates that allowed less skilled workers to produce consistent results. Corporal Washington trained welders in the specific techniques required for the collar joints. Together, they transformed what had been a handcrafted prototype into a manufacturable system. The psychological challenges were as significant as the technical ones. Webb was now working directly with senior British and American officers, many of whom had never collaborated with a black officer in a position of technical authority. Some adapted quickly, recognizing competence regardless of its source. Others maintained a careful distance, their discomfort obvious but usually unspoken. Lieutenant Colonel Geoffrey Hastings, the Royal Engineer officer assigned to supervise production, initially insisted on reviewing every decision Webb made. The first morning, Hastings arrived at the workshop with a clipboard and a patronizing smile, clearly expecting to find amateur work that would need correction. He watched as Webb examined a welding seam under magnification, measuring the penetration depth with calipers. "That joint looks acceptable to me, Webb. We should move forward with production." Webb did not look up from his examination. "The penetration is only 4 millimeters at this point, sir. The specification requires 6 millimeters minimum for structural integrity under firing stress. This piece needs to be rejected, and the welder needs additional training." Hastings frowned and took the calipers himself, checking Webb's measurement. The reading was exactly as Webb had stated. "I see, and you can identify these deficiencies by sight." After examining several hundred welds, "You develop a sense for what correct penetration looks like, sir. But I always verify with measurement. Engineering is not about intuition, it is about data." Over the next 3 days, Hastings watched Webb catch 6 separate errors that the British officer had missed. A misaligned collar that would have caused the shell to tumble in flight. An incorrect mixing ratio in a batch of filling material that would have made the collar too brittle. A microscopic crack in a shell casing that could have caused catastrophic failure during firing. Each time, Webb explained his reasoning with precision and patience, never making Hastings feel incompetent, but simply sharing expertise. On the 4th day, Hastings arrived without his clipboard. "I say, Webb, you have quite the eye for tolerances. Where did you study engineering?" "Tuskegee Institute, sir, in Alabama." Hastings paused, Processing this information against whatever preconceptions he had carried, his expression shifted through several emotions: surprise, perhaps embarrassment, then something like respect. Well, they certainly taught you properly. I have worked with chaps from Oxford who could not calculate stress loads half as quickly. I must confess I had certain expectations when I learned I would be working under your supervision. Those expectations were entirely incorrect, and I apologize for my initial attitude. The apology caught Webb off guard. Few white officers acknowledged their prejudices so directly. I appreciate that, sir, and for what it is worth, you have been far more willing to learn than many officers I have encountered. Hastings nodded slowly. My father always told me that a good officer learns from anyone who has knowledge to share. I am ashamed it took me 3 days to remember that lesson. Now shall we review the production schedule? I have some thoughts on optimizing the welding sequence, if you are willing to hear them. Always, sir, good ideas can come from anywhere. It was not equality, but it was respect, and respect could sometimes build bridges where formal equality could not. In 1942, Webb had learned to accept what progress he could achieve and to nurture it when it appeared. The workshop itself became a peculiar island of meritocracy within the segregated military structure. British and American soldiers worked side by side with Webb's original team of Washington and Chen, united by the common goal of producing reliable weapons. A private from Tennessee, who had probably never spoken to a black person as an equal, found himself taking instruction from Corporal Washington on proper welding technique. A sergeant from London, who had certainly never met a Chinese American, discovered that Private Chen could machine parts to tolerances he could barely measure. One afternoon, Webb overheard a conversation that crystallized the transformation. 2 American privates were eating lunch near the welding station. One, a farm boy from Georgia named Tommy Matthews, was talking to his companion, a factory worker from Detroit named Carl Brunson. "My daddy told me before I shipped out that I should not take orders from coloreds," Matthews said quietly, clearly struggling with his upbringing. "Said it was not natural, said it would not work. But I have been watching Lieutenant Webb for a week now, and Carl, that man knows things I cannot even imagine. He looks at a piece of metal and sees things that are invisible to me. He explains why things work the way they do, and it all makes sense. I do not know what to think anymore." Brunson, who had grown up in a more integrated environment, responded with patience. "Tommy, my father worked at the Ford plant with colored workers. Some were good, some were not, same as the white workers. What I learned is that being good at something has nothing to do with what you look like. It is about what you know and whether you are willing to work hard. Lieutenant Webb knows engineering, and he works harder than anyone I have ever seen. That is all that matters here." Matthews was quiet for a moment. "I reckon you are right. I reckon my daddy was wrong about some things." Webb pretended not to have heard the conversation, but it stayed with him. Changing one mind, even partially, even temporarily, was still change. If enough minds changed, even in small ways, perhaps the world his children would inherit would be different from the one he had known. The production work continued with growing efficiency. By the second week, the team was producing 15 shells per day, exceeding the initial estimates. Webb implemented a quality control system that caught defects before shells were completed, reducing waste and ensuring consistency. Each shell was numbered and logged, creating a tracking system that would allow any failures to be traced back to specific production batches. He also began documenting everything in meticulous detail. Technical drawings showed every dimension of the collar design. Manufacturing procedures were written out step by step, detailed enough that someone with basic metalworking skills could follow them. Testing protocols specified exactly how to verify each shell's integrity. Webb understood that his presence in this role was temporary. Either the war would end, or he would be reassigned, or military politics would intervene. When that happened, the documentation would ensure the work could continue without him. Chen approached him one evening as Webb was updating the manufacturing manual by lamplight. "Sir, you are creating a legacy here. This documentation is better than what most factories produce for their standard products." Webb glanced up from his work. "The Army has a short memory, Private Chen, and it has an even shorter memory for contributions from people like us. If this design is going to continue being useful after I am gone, It needs to be documented so thoroughly that my absence does not matter. The shells will speak for themselves, but only if someone knows how to make them correctly. Chen understood the subtext. You are making yourself replaceable so the work can outlast you. Exactly. The worst thing I could do is create a system that only works when I am personally involved. That gives people an excuse to abandon it the moment I am no longer convenient. But if anyone can follow the procedures and produce reliable results, then the design becomes part of the standard arsenal, and it does not matter who created it. It was a pragmatic approach born from hard experience. Webb had seen too many innovations from black soldiers and scientists get quietly shelved after the war, dismissed as wartime expedients rather than genuine advancements. He was determined that would not happen to the penetrator shell. By November 28th, they had produced 117 shells that met Webb's quality standards. Another 23 had failed testing and been set aside for analysis. The success rate was acceptable for a new weapon system, but Webb wanted better. He spent his evenings studying the failures, identifying which manufacturing variations led to poor performance. The tactical situation provided an urgent deadline. Allied forces were preparing to assault a fortified German position at a place called Teburba, 40 kilometers west of Tunis. Intelligence indicated the Germans had transformed the town into a heavily fortified strongpoint, with at least 8 reinforced bunkers positioned to create interlocking fields of fire. Standard artillery had already proven ineffective during preliminary bombardments. Casualty estimates for a direct assault were catastrophic. Major General Harrison called Webb into his command tent on November 30th. We are deploying your shells at Teburba. The assault begins in 48 hours. We will have 6 105mm howitzers in direct fire positions, allocated 20 shells each. I need you to brief the gun crews personally on handling and employment procedures. Webb felt the weight of those words. 120 shells, potentially 120 chances to prove or disprove his design under actual combat conditions. Sir, I would like to observe the engagement if possible. Harrison studied him for a long moment. This is not a request for glory, is it? Lieutenant. No, sir. If there are failures, I need to understand why immediately so we can adjust manufacturing procedures, and the gun crews will be more confident if they see that I am willing to stake my own safety on the design's reliability. Very well, you will deploy with the fire support element, but you will observe only no heroics. We need you alive to improve the design, not martyred to prove a point. Clear? Clear, sir. The artillery positions were established on low ridges 800 meters from Teburba's outskirts. Webb spent December 1st working with the 6 gun crews, explaining the shell's unusual characteristics. The crews were professional and attentive, but he could sense their underlying anxiety. They were being asked to bet their lives and their comrades' lives on untested technology, designed by an officer most of them had never heard of before yesterday. Sergeant Major William Davies, a Welsh artilleryman with 18 years of service, asked the question Webb knew was on everyone's mind. Sir, what happens if one of these shells fails in the barrel? Are we going to be picking shrapnel out of our backsides? It was a fair concern. Webb had designed safety factors into the collar, but there were no guarantees. Sergeant Major, I have fired 3 of these shells personally and observed tests of 20 more. None failed catastrophically. The collar is designed to fail safely if it fails at all. It would shed pieces rather than explode. But I will not lie to you, there is risk. There is always risk. Davies respected honesty. Fair enough, sir. We will give your bottle rockets a proper go. Bottle rockets. The nickname would stick, but Webb did not mind. Soldiers always nicknamed their weapons. Affectionate mockery was better than rejection. The assault on Teburba began at dawn on December 2nd, with a conventional artillery barrage designed to suppress German positions and create dust and smoke for concealment. Webb watched from an observation post alongside the forward artillery controller, Captain Michael Brennan, an Irish-American officer from Boston with a reputation for coolness under pressure. The observation post was a hastily reinforced position on a low ridge, sandbags stacked 3 high with a narrow aperture for viewing the battlefield. The morning air was cold, the desert temperature having dropped significantly overnight. Webb could see his breath as he raised his binoculars. Brennan studied the target area through his own optics, a cigarette dangling from his lips despite the obvious fire hazard. Right, Webb. There is our primary target. Bunker designated Objective Baker. Concrete reinforced position, walls estimated at 1.5 meters thickness, housing what we believe is a heavy machine gun and crew of 6. 2 previous bombardments caused no significant damage. This is your show. Through his binoculars, Webb could see the bunker clearly. It was a squat, ugly structure with a narrow firing slit, positioned to enfilade any troops advancing through the town's main approach. The concrete was pockmarked from previous shelling, superficial damage that had done nothing to compromise its defensive value. Men would die attacking that position if it was not neutralized. Webb felt the weight of the moment settling on his shoulders. Months of work, all the testing, all the refinements, all the promises he had made, everything came down to this. If the shell failed, if his calculations were wrong, if the design proved ineffective against a real target under combat conditions, the consequences would extend far beyond his personal reputation. Soldiers would die, and the opportunity he had been given to prove his worth, to show what he was capable of, would evaporate. Brennan seemed to sense his tension. First time under fire, Lieutenant? Yes, sir. I have been in theater for months, but this is my first time in a forward position during actual combat. The captain nodded, his eyes never leaving the battlefield. The fear never entirely goes away. You just learn to work through it. And Webb? Your shells are going to work. I have seen the test results. I have read the technical documentation. You know your business. Trust that. The words helped. Webb took a slow breath, forcing himself to focus on the technical aspects rather than the emotional weight. Range 750 meters. Wind approximately 8 kilometers per hour from the east. Target stationary. All factors well within the shell's performance envelope. Brennan spoke into his radio, his voice calm and professional. Fire mission Gun 3. Target reference Objective Baker. 1-round penetrator shell, range 750 meters, bearing 270 degrees, direct fire. The response crackled back almost immediately. Gun 3 ready, 1-round penetrator, firing. Webb found himself holding his breath. This was different from the test range. This was a real target, real stakes, real lives depending on the outcome. Through the binoculars, he could see infantry soldiers crouched in covered positions, waiting for the bunker to be neutralized before they advanced. Young men, probably not much different from the students he hoped to teach someday, their lives hanging on whether his engineering calculations were correct. The howitzer's report was audible even at this distance, a sharp crack that echoed across the battlefield. The shell's flight seemed to take forever, though Webb knew from calculations it was less than 3 seconds. He tracked the trajectory through his optics, watching the distinctive bottle-shaped projectile arc toward its target. Impact. The sound was that distinctive, deeper boom that he had first heard at the testing ground in Alexandria, but hearing it in combat added a visceral element the tests had lacked. Through the binoculars, he watched the concrete structure shudder violently. Dust erupted from every seam and joint, a grey cloud that momentarily obscured the entire bunker. The firing slit, previously a dark rectangle from which machine gun fire could pour, now showed only rubble and shattered concrete. For a heartbeat, nothing happened. Then the entire front section of the bunker collapsed inward, the structural integrity so thoroughly compromised that the weight of the remaining concrete could not be supported. It was not an explosion in the Hollywood sense. There was no fireball, no dramatic shower of debris flying hundreds of meters. Instead, it was a methodical structural failure, the building essentially eating itself as weakened sections gave way and pulled adjacent sections down with them. Brennan was already calling for a damage assessment from forward observers positioned closer to the target. The response came within seconds, the observer's voice carrying a note of amazement. Objective Baker shows catastrophic structural failure. Front wall collapsed. Rear wall shows major fracturing. No observed activity from bunker. No defensive fire. Bunker assessed as neutralized. Repeat, neutralized. 1 shot, 1 bunker destroyed. Webb felt a wave of relief so intense it was almost physical. His hands were shaking as he lowered the binoculars. The design worked. not in a controlled test with carefully measured targets, but against a real enemy fortification under actual combat conditions. It worked, but there was no time to celebrate. Brennan was already moving on to the next target. Outstanding, Webb. Absolutely outstanding. Now let us see if that was luck or if we can replicate it. Gun 5, prepare for fire mission. Target reference objective Charlie. Over the next 90 minutes, Webb watched as the artillery crews methodically engaged each fortified position. The penetrator shells, he was already thinking of them by Davies's nickname, the bottle rockets, performed with remarkable consistency. Gun 4 engaged a bunker designated Objective Delta, the shell penetrating the concrete facade and detonating deep inside. The bunker did not collapse as dramatically as the first one, but the internal explosion was clearly visible through the firing slit, flames and smoke jetting outward. Forward observers reported no survivors and no further defensive fire from that position. Gun 6 targeted Objective Echo, a larger bunker complex that intelligence believed housed both machine guns and a mortar position. The first shell struck slightly high, glancing off the reinforced roof and detonating in the air behind the structure. Webb's heart sank. A miss. But the gun crew adjusted quickly, lowering the elevation slightly for the second shot. This time, the shell struck squarely on the front wall, penetrated, and the resulting explosion collapsed an entire section of the bunker. German soldiers were seen evacuating the position, abandoning their weapons in their haste to escape. Of the 18 shells fired at bunker targets during the initial bombardment, 16 achieved penetration and structural failure. 2 struck at angles that caused the shells to glance off rather than penetrate fully. But even these impacts created sufficient damage to force the defenders to abandon their positions. The psychological effect was clear. Soldiers who had felt safe behind meter-thick concrete were now frantically evacuating before the next shell arrived. Brennan observed the results with professional satisfaction. Webb, I have been directing artillery fire for 4 years in North Africa, in Sicily in half a dozen engagements. I have never seen anything this effective against reinforced positions. Not even close. You have changed the calculus of urban warfare. The praise meant something, coming from a veteran like Brennan. But Webb's attention was drawn to the infantry beginning their advance. Soldiers moved through sectors where the primary defensive positions had already been eliminated, their pace confident rather than the desperate rush that characterized advances under machine gun fire. They paused to clear buildings, working methodically rather than frantically. The difference was stark. A young lieutenant leading one of the infantry platoons, a man named Harrison Foster from Kentucky, would later write in a letter to his parents, "We expected to lose half the platoon taking that town. The intelligence brief was grim. Fortified positions, interlocking fields of fire, the kind of setup that turns an advance into a slaughter. But then the artillery did something I have never seen before. They fired these odd-looking shells, and the bunkers just came apart. By the time we moved in, the German defensive line had collapsed. We took casualties, but nothing like what we expected. Someone in the artillery saved a lot of lives today." Foster never learned the name of the black engineer who had designed those odd-looking shells, and Webb never knew about Foster's letter. But the connection was there nonetheless, an invisible thread linking innovation to survival, engineering to humanity. Webb walked among the destroyed bunkers after the fighting ended, studying the damage patterns with a professional's eye. Each penetration showed the characteristic signature of his design, deep entry wounds that penetrated to the structure's core before detonation. In one case, the shell had gone completely through the front wall, detonated inside and blown out the rear wall, almost exactly replicating the test results from Alexandria. He found one of the German survivors, a young soldier named Klaus Bergmann, who spoke some English, being treated by Allied medics for shock and a broken arm. Bergmann looked at Webb with an expression mixing fear and confusion. "What kind of shell was that? We were told the concrete would protect us. Nothing was supposed to penetrate that deep." Webb felt no satisfaction in the young man's distress. Bergmann was perhaps 20 years old, a conscript who probably had no more choice about his presence in North Africa than Webb had about facing prejudice in his own army. "A new design. I am sorry you were injured." Bergmann shook his head slowly. "My sergeant, he said the bunker was safe. He said we just had to wait for the assault, let the machine gun do its work. Then that shell came through the wall like it was paper. The whole bunker came apart. I thought I was dead. That night back at headquarters, Webb filed a detailed after-action report documenting the engagement. Of 120 penetrator shells produced, 18 had been used at Teburba, with an 89% effectiveness rate. The remaining shells would be distributed to other units, preparing to assault fortified positions in Tunisia. Major General Harrison read the report with obvious satisfaction. "Lieutenant Webb, this is exceptional work. I am putting you in for a commendation and recommending you for promotion to captain. Additionally, I want you to begin training other ordnance officers in the manufacturing process. We need production expanded significantly." The commendation would eventually arrive, though the promotion would be delayed for reasons that were never officially explained, but that Webb understood perfectly. The Army in 1942 had quotas and expectations about black officers' advancement that had nothing to do with merit, but the professional recognition mattered more than rank. For the first time in his military career, Webb was being valued for his engineering expertise rather than categorized by his skin color. Over the following months, the penetrator shell, now officially designated the T-15 bunker penetrator shell, but universally known as the bottle rocket, became standard equipment for artillery units facing fortified positions throughout the Mediterranean theater. Production expanded to facilities in England and eventually to the United States. By June 1943, more than 4,000 shells had been manufactured. The weapon's impact extended beyond its tactical effectiveness. It represented a validation of field innovation over institutional procedure. Webb's design had not emerged from the Ordnance Research Establishment at Aberdeen Proving Ground, but from a segregated maintenance unit in North Africa. The implications challenged assumptions about where innovation could originate and who was capable of producing it. Perhaps more significantly, the bottle rocket's success created opportunities for other black engineers and technical specialists in the military. When the Quartermaster Corps began seeking engineers for a new logistics system, they included qualified black officers in the candidate pool, something that would have been nearly unthinkable a year earlier. When the Army Air Corps needed technical advisors for bomber modification programs, several black mechanics and engineers received assignments based on demonstrated competence, rather than being automatically excluded. Webb himself became a sought-after consultant on weapons development. He advised on modifications to anti-tank weapons, consulted on bridge demolition charges, and helped redesign ammunition storage systems to improve safety. Each project brought him into contact with senior officers and civilian engineers who might never have worked with a black professional in a position of authority. The personal cost of his achievement was something Webb rarely discussed. The endless hours in workshops had taken a toll on his health. The constant pressure of proving himself to skeptics, of knowing that any failure would be attributed not just to him personally, but to his entire race, created a stress that his white colleagues never had to bear. The quiet satisfaction of having his suggestions dismissed by junior officers who would never have questioned a white colleague's expertise. The knowledge that despite his contributions, he would return to a segregated America where many states would not allow him to vote. In late July 1943, Webb received orders transferring him to London to work with British and American planners preparing for the invasion of France. His expertise would be needed for developing specialized munitions to defeat the Atlantic Wall fortifications. It was recognition of his value, and he accepted the assignment with pride. Before leaving North Africa, he visited the Ordnance Depot where he had first fabricated the prototype penetrator shell. Corporal Washington and Private Chen had both been promoted, Washington to sergeant and Chen to corporal, and were now training new production crews. Washington shook Webb's hand with genuine warmth. "Sir, I just want to say it has been an honor working on this project. My father worked in a steel mill in Pittsburgh his whole life. Nobody ever asked him what he thought about anything. He just did what he was told. But here, you asked for my ideas. You listened when I suggested changes. You treated me like I knew something worth knowing." Webb felt his throat tighten. "You did know something worth knowing, Sergeant. Your welding work was crucial to making the design work. Do not ever forget that." Chen added his own thoughts. My family is still in a camp in California, sir. They are being held because people think they cannot be loyal Americans. Every time I see one of these shells being loaded, I think about proving them wrong. Every bunker we take down is proof that we all have something to contribute. These were the things that would stay with Webb long after the technical details faded. The knowledge that his work had created space for others to demonstrate their worth, that in some small way he had challenged the assumptions that limited what people like him were allowed to achieve. The bottle rocket's final combat use came during the Normandy invasion in June 1944. Modified versions of Webb's design, now refined through months of testing and battlefield experience, were deployed against German coastal fortifications. Gun crews fired penetrator shells at reinforced bunkers overlooking the landing beaches, destroying positions that could have inflicted massive casualties on Allied troops. A young lieutenant named Thomas Morrison, leading a platoon at Omaha Beach, later wrote in his memoir about watching a German bunker that had been raking his position with machine gun fire suddenly erupt in a cloud of concrete dust after being struck by what he called that beautiful bottle-shaped shell. He described reaching the bunker minutes later and finding it completely destroyed from within, the thick concrete walls blown apart as though from an internal explosion. That bunker would have been responsible for dozens of American deaths if it had remained operational. Instead, Morrison's platoon advanced inland with minimal casualties. Morrison never learned the name of the engineer who had designed the shell that saved his life and the lives of his men. Webb, working in a London planning office at the time, never knew about Morrison's specific experience, but he knew the shells were being used at Normandy, knew they were saving lives, and that knowledge sustained him. After the war ended, Webb returned to the United States with the rank of captain. The delayed promotion had finally come through in late 1944, though he suspected it arrived only because the war was winding down and the Army felt it could afford some gestures toward fairness. He boarded a transport ship in Southampton in August 1945, watching the English coastline recede with mixed emotions. Europe had been exhausting, challenging, often frustrating, but it had also been the place where his abilities had finally been recognized, where he had made a tangible difference. The ship docked in New York Harbor on a gray September morning. Webb stood at the railing with hundreds of other soldiers, watching the Statue of Liberty emerge from the morning mist. The symbolism was not lost on him, returning to a country whose ideals of liberty and equality did not extend to everyone. He had helped defeat totalitarian regimes in Europe, but he was coming home to a nation where he could not vote in many states, could not eat in many restaurants, could not stay in many hotels. The Army separated him from service in November 1945 at Fort Dix, New Jersey. The process was efficient and impersonal. A clerk reviewed his service record, noting his decorations, a Bronze Star for meritorious service, various campaign medals, the testimonials from senior officers. The clerk, a white corporal who looked barely old enough to shave, processed the paperwork without ever making eye contact. Webb wondered if the young man even realized he was dismissing an officer, or if the skin color was all he saw. He returned to Detroit and found a city transformed by the war, yet stubbornly unchanged in its fundamental character. The factories that had produced tanks and aircraft were retooling for civilian production. Jobs were plentiful for returning white veterans. For black veterans, opportunities were more limited. Webb applied for engineering positions at Ford, General Motors, Chrysler, and a dozen smaller firms. His credentials were impressive: a degree from Tuskegee, wartime service as an ordnance officer, documented innovations in weapons design, but the responses were uniformly polite and uniformly negative. The positions had been filled. They would keep his application on file. Perhaps something might open up in the future. After 6 months of rejections, he accepted a teaching position at Tuskegee Institute at a salary 1/3 of what he would have earned in private industry. It was not what he had hoped for, but it was meaningful work. He would teach the next generation of black engineers, preparing them for a world that might, eventually, be more welcoming than the one he had known. His students found him demanding but inspiring. He insisted on rigorous standards, accepting no excuses for sloppy work or incomplete calculations. "The world will judge you more harshly than it judges white engineers," he told them bluntly. "You cannot afford to be merely competent. You must be exceptional. It is not fair, but it is reality. I am here to prepare you for that reality." But he also shared his wartime experiences, the moments when his engineering expertise had made the difference between success and failure, life and death. He wanted his students to understand that their education was not abstract, that the principles they learned in classrooms could have real-world impact. He told them about the bottle rocket, about the skepticism he had faced, about the satisfaction of seeing his design work under combat conditions. One student, a young woman named Sarah Mitchell from Birmingham, Alabama, asked him during office hours, "Professor Webb, when you faced all that doubt, all those people who did not think you could succeed, how did you maintain your confidence?" Webb considered the question carefully. "I will be honest with you, Miss Mitchell. There were moments when I doubted myself. When you hear enough people tell you that you are not capable, some part of you starts to wonder if they might be right. But I had something stronger than confidence. I had evidence, I had calculations, I had test results. When people doubted me, I could point to data. I could demonstrate through mathematics and physics that my design would work. That is the power of engineering. It is not about opinion or prejudice. It is about whether the numbers add up." He paused, then added, "But I also had anger. I was angry that I had to prove myself twice as much as a white engineer would. I was angry that my innovations were met with skepticism, while mediocre ideas from white officers were given immediate consideration. I learned to channel that anger into determination. Every time someone dismissed my ideas, I worked harder to prove them wrong. It was exhausting, and it should not have been necessary, but it kept me going." Mitchell nodded slowly, absorbing this. "Did you ever get the recognition you deserved, Professor?" "That depends on how you define recognition, Miss Mitchell. I received some military commendations. Some technical reports cite my work. But if you mean public acknowledgement, newspaper articles, the kind of recognition that creates opportunities and changes how people see you, no, I did not receive that. And I probably never will. Most people have no idea that the bunker-busting shells used at Normandy were based on principles I developed in a North African workshop. My name appears in some military archives, but nowhere the general public would see it. Does that bother you?" Webb thought about lying, about giving her an inspiring answer about how the work itself was reward enough, but he respected her enough to be honest. "Yes, it bothers me. I am human. I would like to be recognized for my contributions. I would like my children, if I ever have children, to see their father's achievements acknowledged. But I also know that recognition is not the point. The point is that I saved lives. Soldiers survived battles because of my design. They went home to their families. They lived full lives. Whether they know my name or not does not change that fact." Mitchell graduated in 1951 and went on to work for NASA during the space program, one of many Tuskegee graduates who contributed to aerospace engineering. She would later credit Webb with teaching her that excellence was the best response to discrimination, that technical competence could force open doors that prejudice tried to keep closed. In 1953, a young engineering student from MIT named David Fletcher, researching bunker-busting weapons for his master's thesis, discovered Webb's name buried in an obscure War Department technical document. The document, titled Field Modifications to Standard Artillery Munitions, North African Theater, 1942 to 1943, included a detailed description of the T-15 bunker penetrator shell, with a footnote attribution to First Lieutenant Marcus J. Webb, 51st Ordnance Battalion. Fletcher was intrigued. The design showed clear innovation, yet he could find almost no other references to Webb in military literature. He wrote a letter to the War Department requesting more information and received a terse response that Lieutenant Webb had served with distinction and had been separated from service in 1945. No current contact information was available. Undeterred, Fletcher contacted Tuskegee Institute on the chance that a black officer with an engineering background might have connections there. The registrar confirmed that Marcus Webb was indeed on the faculty and provided a campus address. Fletcher drove from Boston to Alabama to conduct an interview, a trip that opened his eyes to the realities of segregation in the South. Their conversation took place in Webb's small office, a cramped space lined with bookshelves and dominated by a large drafting table. Fletcher, nervous about interviewing a man whose work he admired, asked the question that got to the heart of Webb's experience. "Professor Webb, when you first presented your design and faced all that skepticism, did you ever consider giving up? Did you ever think it was not worth the struggle?" Webb considered his answer carefully, measuring his words. Giving up would have been easier, certainly. The skepticism was draining, especially because I knew that much of it had nothing to do with the design's merits. People doubted me because of who I was, not because of any flaw in my engineering. That kind of prejudice is exhausting to confront day after day. He stood and walked to the window, looking out at the campus. But I kept thinking about the soldiers who would have to attack those bunkers if we did not find a better way to neutralize them. I thought about young men, 18 or 19 years old, being ordered to run across open ground toward machine guns. Boys who had mothers waiting for them at home, sweethearts writing them letters, entire lives ahead of them. And I thought that if I had a solution, even one that looked ridiculous, even one that people laughed at, I had a moral obligation to pursue it. The mockery I faced was nothing compared to what those soldiers would have faced. He turned back to Fletcher. There was also something else. I knew that if I failed, people would say it was because I was not capable, and they would use that as evidence that people who looked like me should not be trusted with important responsibilities. That was unfair, and it was an extra burden that white engineers did not have to carry. But it was also reality. I was not just representing myself. Whether I wanted to or not, I was representing my entire race in the minds of many people who worked with me. So I made certain I did not fail. I could not afford to fail. Fletcher's thesis, completed in 1954, helped bring wider attention to Webb's contribution. He dedicated an entire chapter to the development of the T-15 shell, carefully documenting Webb's role through military records and personal interviews. The thesis was well received in academic circles, and Fletcher sent Webb a bound copy with a note expressing his admiration. Military historians began citing Webb's work when discussing the evolution of bunker-busting technology. Articles appeared in specialized journals, though rarely in mainstream publications. The modern bunker-buster bombs, with their hardened casings and delayed fuses designed to penetrate deep underground before detonating, owed a conceptual debt to the principles Webb had first demonstrated with his ungainly collar design. But Webb's greatest satisfaction came not from academic recognition, but from the occasional letter he received from veterans. In 1958, a man named Robert Harrison from Kansas wrote to him after reading Fletcher's thesis in a library. Harrison had fought in Tunisia as an infantry sergeant and remembered the strange bottle-shaped shells that had destroyed German bunkers before his company's attack on a fortified town. "I never knew who designed those shells," Harrison wrote. "We just knew they worked. They saved a lot of lives, including probably mine. My platoon would have taken heavy casualties attacking those bunkers with conventional support. Instead, we walked through positions that had already been neutralized. I went home, married my sweetheart, raised 3 children, built a good life. All because someone I never met designed a weapon that worked. Thank you, sir. Thank you for bringing me home alive." Webb kept that letter in his desk drawer and reread it whenever he felt discouraged about the lack of broader recognition. Harrison's gratitude meant more than any medal or newspaper article could have. Marcus Webb passed away in 1971 at the age of 57, from heart disease likely exacerbated by the stresses he had endured throughout his life. His obituary in the Detroit newspaper mentioned his wartime service but said nothing about the penetrator shell. It was left to his former students and colleagues to preserve the story of his achievement. Today, the few remaining examples of the T-15 bunker penetrator shell reside in military museums, their bottle-shaped profiles still drawing curious looks from visitors who wonder about their unusual design. The explanatory plaques typically mention the shell's effectiveness, but rarely name its creator. That anonymity would probably not have bothered Webb. He had never sought fame, only the opportunity to use his skills to make a difference. The broader significance of his story lies not just in the technical innovation, but in what it revealed about talent and potential existing in places the establishment never thought to look. Every segregated unit that produced leaders, every discriminated against group that contributed to the war effort despite facing prejudice, every individual who overcame institutional barriers to make their mark, they all challenged the assumptions that said certain people belonged in certain roles and nowhere else. The bottle rocket remains a footnote in military history, but it is a footnote worth remembering. It represents a moment when necessity forced a partial suspension of prejudice, when lives depended more on results than on the color of the engineer who produced them. It was not equality. The army remained segregated, opportunities remained limited, and Webb's recognition remained incomplete. But it was progress, achieved one destroyed bunker at a time, by a man who refused to accept that his ideas were worth less because of who he was. The soldiers who survived because of his innovation never knew his name. The families who welcomed home sons and husbands who might otherwise have died attacking bunkers never knew who to thank. But Marcus Webb knew, and that knowledge sustained him through all the disappointments and limitations that followed. He had saved lives. He had proved that brilliance and determination could overcome skepticism and prejudice, at least temporarily, at least partially. In the end, perhaps that was enough. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Do not forget to subscribe for more untold stories from World War II, and check out the video on screen for another incredible tale from history. Until next time.